Every morning after 60, your heart muscle is quietly losing something. Not slowly, rapidly. And it's not calcium, it's not collagen, and it's not anything your doctor has almost certainly ever warned you about. By the time you feel it, the stairs getting harder, the groceries feeling heavier, the breath catching sooner than it used to, nearly a third of the signal keeping that muscle strong is already gone. There is one specific protein driving this entire process. Most research on it is less than 3 years old, and by the end of this video, I'm going to show you exactly what it is, why it's failing inside you right now, and the precise 3-step routine you can use to protect it starting tonight. I'm Dr. Richard James, cardiologist. I've spent more than 30 years focused on cardiovascular and longevity medicine. And what I'm about to walk you through comes out of peer-reviewed research most of my own colleagues have not had time to read yet. Here's the part nobody sat you down and explained. The first muscle that weakens after 60 is not in your legs, it's in your chest. The cardiac muscle that pushes blood to every inch of your body loses contractile power on a measurable timeline after 50. And for most seniors, that is where the feeling of aging actually begins. This matters because heart muscle weakness is what turns "I can still carry my own groceries" into "I can't manage the stairs anymore," on a timeline most people never see coming. It is a silent crisis, and it wears the mask of ordinary aging. Here's what makes this so frustrating. If you've been lifting light weights, eating the protein shakes, walking every morning, doing everything the magazines and the labels told you to do, and your strength is still slipping away, it is not you. There is a biochemical signal inside your cells that goes quiet after 60. Without it, the gym work, the protein, the sleep, none of it lands the way it used to. I'll name the specific protein responsible later in this video. For now, I need you to hold on to one idea. The problem is not your effort. The problem is a molecule. Here's what nobody in medicine sat you down and explained. Your heart is a muscle. It ages like a muscle. But it is the one muscle you cannot feel getting weaker until the day your body starts forcing you to rest. Picture a woman in her early 70s. Let's call her Margaret, though she could be anyone with this profile. A retired public library director from Cleveland, 72 years old, widowed 2 years ago, living alone in a split-level house where the laundry room sits at the bottom of 12 stairs. She walked into a clinic last winter convinced her legs were giving out. She had cut her protein up. She had bought a set of resistance bands. She had done the exercises she saw online, and she kept getting weaker. Her legs were fine. Her quadriceps were fine. The echocardiogram told the real story. Her heart was moving less blood per beat than it had a decade earlier, and every downstream system, balance, breath, recovery, walking speed, was being starved a little bit, every single day, without anyone measuring it. That is what muscle aging actually looks like in most seniors over 60. It is not a leg problem, it is a pump problem. And once you see it that way, a lot of things click into place. The handrail on the stairs that used to feel decorative now feels necessary. The short walk to the mailbox that leaves you slightly winded. The shopping trip that used to take 90 minutes and now takes 2 hours because you need to sit down twice. Those are not just age. Those are cardiac output signals, arriving in code, hoping somebody decodes them before the real damage is done. And here's the part most people get wrong. They feel the symptom, they blame their legs, they double down on leg strengthening, and nothing changes. The signal keeps flashing, louder and louder, because the actual problem was never the legs. Think about that for a moment. If you have noticed yourself sitting down more often, pausing at the top of the stairs to catch your breath, shortening your errands, taking the shopping cart instead of the basket. Those are not failures of willpower. They are your heart muscle trying to tell you, in the only language it has, that the pump is falling behind demand. And when we measure it in clinic, that signal is almost always there years before any traditional heart attack symptom appears. That is why I call this the silent crisis. Not because it is invisible on a test, because it is invisible to the person living it. So why does the gym not fix it? Why doesn't the protein shake fix it? The answer is in something most doctors have never heard the name of. And that brings us to the question every researcher in cardiovascular aging has been quietly chasing for the last 5 years. You've been told to eat more protein. You've been told to lift weights. And for most people under 60, That advice does exactly what it promises, because their cells are still listening. After 60, the signal fades. The protein arrives. The muscle fibers just don't hear it the way they used to. Your body receives the fuel, but the messenger carrying the instructions inside the cell has quietly stepped aside. This is a documented shift, not an opinion. Researchers who study aging muscle have described it for years as anabolic resistance. The older adult requires a higher threshold of protein, timed more precisely, to produce the same cellular response that a 30-year-old gets from a handful of almonds. Work published in the American Journal of Clinical Nutrition and Nutrition and Metabolism has documented this threshold repeatedly, and work on cardiac-specific protein homeostasis, including emerging data in Nature Aging and circulation research, now shows that the aging heart muscle has its own version of this problem. The heart cells are still there. The protein is still arriving. The signaling step in between is the part that goes silent. That is why you can do everything right and still watch the strength slip through your fingers. It is not your effort. It is a molecule that has gone quiet. And here is where it gets genuinely interesting. The research community has spent years asking which molecule is most responsible. For a long time, the answer was probably several, a list of usual suspects. Then, in the last 2 to 3 years, a single protein started appearing at the center of the picture. Not because anyone was looking for it, but because it kept showing up wherever aging muscle was failing. Before I name it, there is one more thing you have to understand, because without it, the 3-step routine I'm about to give you will not stick. The cells in your heart muscle do not lose this signaling protein evenly. They lose it fastest during 2 windows: the hours after a meal without movement, and the hours of shallow, fragmented sleep. Those 2 windows are where the decay compounds. Fix those windows and you slow the loss. Ignore them and no supplement will rescue you. Now, let me give you the name. The protein is called NDRG1. NDRG1. It stands for N-MYC downstream regulated gene 1, which is a mouthful. So from here on, I'll just say NDRG1. And if you've never heard of it before, you are not alone. Most physicians outside of aging research have not either. The human literature on NDRG1 in aging muscle is young. Much of the most direct muscle aging data still comes from animal and cellular models, with human studies catching up in the last few years. I want to be honest with you about that. This is early science, and I'm showing it to you because the mechanism is already clear, and the levers that support it are things that help you anyway, regardless of how the final research lands. Here's what NDRG1 does, in plain English. It is the molecule that tells your muscle cells, including your heart muscle cells, how to respond to stress, to exercise, and to repair signals. Think of it as the switchboard operator inside the cell. When it is robust, every call connects. When it fades, calls start dropping. When NDRG1 is strong, your body hears every workout, every piece of protein, every good night of sleep. The signal goes through. The repair machinery turns on. The heart muscle contracts a little harder the next day. The leg muscles respond to the walk. The recovery happens the way it used to. When NDRG1 fades, your cells go partly deaf. The protein arrives. The exercise happens. The sleep comes. But the command that tells the cell, now rebuild, now adapt, now get stronger, arrives as a whisper. And over the years, that whisper is what you feel as weakness. Research published across muscle aging and cellular stress biology has pointed to NDRG1 as a central node in this failure. It appears in pathways that regulate lipid metabolism inside muscle cells, in pathways that control how cells respond to low oxygen stress, and in the repair cascades that follow any kind of mechanical load. When NDRG1 is expressed normally, those systems hum. When it drops, those systems sputter. Here is what that translates to in everyday life. A cell with strong NDRG1 signaling does not waste fuel. It uses the fats and sugars available to it efficiently, which matters enormously for heart muscle, because your heart runs on fatty acids and is exquisitely sensitive to how well it can burn them. A cell with fading NDRG1 signaling starts handling fuel clumsily. The heart works harder to produce less force. The legs recover slower from the same walk. The recovery you used to get from a single good night of sleep now takes 2 nights, then 3. None of that shows up on a standard blood panel, but it is the quiet texture of most senior weakness I see in clinic. And here is the part I want you to hold on to. NDRG1 is not a vitamin. There is no pill at the pharmacy that boosts it directly in humans. What the science does suggest, however, is that the way you move, the way you eat, and the way you sleep influence the cellular conditions under which NDRG1 functions. That is the actionable opening. Now, I know exactly what some of you are thinking because I would be asking the same question. If this protein is so central, why has my doctor never mentioned it? If it were real, wouldn't it be in the guidelines by now? The honest answer is that clinical guidelines trail published research by 5 to 10 years on average. That is not a flaw. That is how medicine is supposed to work. Safety takes time. Guidelines are built to protect populations, not to chase the edge of the literature. The edge of the literature is where researchers live. The guidelines are where your primary care doctor lives. Both of those things can be true, and both are useful. The second question some of you are asking is fair too. Is this just a setup for a supplement pitch? No. I am not going to tell you to buy a pill. I am telling you the opposite. I am not asking you to stop lifting, stop walking, or stop eating protein. I am explaining the gate those things have to pass through to reach your heart muscle. When the gate is open, everything works. When the gate closes, nothing does. There is one more layer to the mechanism, because I want you to understand why the 3 steps I'm about to give you matter in the exact order I give them. NDRG1 responds to 3 inputs that your body has full control over. Mild, repeated physical stress, the presence of amino acids at the moment of that stress, and the deep repair window of protected sleep. If you hit all 3, you create the cellular conditions where this signaling protein can do its job. Miss even one, and the other 2 carry only a fraction of their weight. Nothing in this routine is exotic. No injections, no expensive supplements, no prescription. It is lifestyle applied with precision. And if your current routine is already working for you, keep going. If it stopped working after 60, the next 90 seconds will explain why and what to adjust. So here is exactly what I want you to do, starting tonight. Step 1. Short, dense movement 3 times a day. Not long walks, not endurance. I want you to pick 3 moments in your day, morning, midday, and evening. And in each one, move deliberately for 90 seconds. Sit to stand from a sturdy chair, 10 repetitions. Wall push-offs, 10 repetitions. A brisk hallway walk you can just barely sustain. The physiological goal is to deliver repeated, brief pulses of mild mechanical and metabolic stress, which is the exact input muscle cell stress response pathways are wired to respond to. One long session does not produce the same signal. 3 short ones do. Step 2. Protein timing, not protein quantity. Within 30 minutes of each of those 90-second bouts, eat roughly 25 to 30 grams of protein. 2 eggs, a piece of fish, a small portion of Greek yogurt, a modest chicken breast. What matters is that the protein arrives while the cell is still activated from step 1. Senior muscle is less sensitive to protein signaling, so the fix is not to eat more protein overall. It is to present the protein at the exact moment the machinery is listening. This is how you get around anabolic resistance without having to triple your daily intake. Step 3. Protect your sleep window, 10 p.m. to 6 a.m. No caffeine after 2 in the afternoon. Screens off 60 minutes before bed. Room cool, room dark. Most of the cellular repair that depends on signaling proteins like NDRG1 happens during deep, undisturbed sleep. The kind that fragments quickly in older adults when the room is warm, the phone is active, or a second cup of coffee is still metabolizing at midnight. This is the step most people skip. It is also the step that decides whether the first 2 steps carry full weight or half weight. Skip it, and you are doing the work with the volume turned down. Do that routine for 30 days, and here is what you should notice in this order. First, sleep improves. By week 1, most people report deeper, less fragmented nights. Second, recovery. By week 2, the stiffness after activity fades faster. Third, capacity. By week 3 or 4, the stairs, the grocery carry, the walk to the mailbox, they all feel a measurable notch easier. That progression is the signal that the cellular conditions supporting signaling proteins like NDRG1 are shifting in your favor. Your heart muscle has been aging on a timeline you could never see. Now you can. You know the protein, you know why it fades, and you know the 3 things you can do, starting tonight, to keep it strong. The information existed, the levers were always there. Now you have them. Next week, I'm going to show you the one heart muscle test you should be asking for after 60. The one most cardiologists won't order unless you bring it up yourself. It takes 20 minutes, it costs less than most people assume, and it catches the exact pump strength decline we talked about today, before it costs you your independence. Subscribe so you don't miss it. Take care of your heart tonight. I'm rooting for you. I'm Dr. Richard James.